Okay, so these are my last two examples about the topic fundamental theorem of integral calculus. We have example number 5, the integral of the quantity 3x squared minus 2x plus 1 dx from 1 to 2 as our interval. So evaluate natin gamit yung definite integration. We have that is 3x cubed over 3 minus 2x squared over 2 plus x. Okay? From 1 to 2. So we have x cubed minus x squared plus x. Okay? Then gamit naman yung fundamental theorem of integral calculus, we have f of b minus f of a. So ito yung ating b, ito yung ating a. Substitute lang natin kay x. So we have 2 cubed minus 2 squared plus 2 minus yung 1 naman. 1 cubed minus 1 squared plus 1. 8 minus 4 plus 2 minus 1 minus 1 plus 1 is 1. Okay? So 8 plus 2 is 10 minus 4 is 6 minus 1, 5. So ito yung sagot natin. Okay? So that is our answer for example number 5. Now, for example number 6, sulat ko muna yung ating mga kailangan para ma-solve natin example number 6. Pero madaling paraan para ma-solve to, yung tinatawag natin Wallis formula. Okay? Wallis formula. Hindi ko na ituturo sa inyo yung Wallis formula, pero pwede naman itong ma-solve gamit yung methods of integration. Ang topic natin ay powers of sines and cosines. And these fall down dun sa ating case 3. Okay? So, ilalagay ko sa inyo kung paano, mamaya, kung paano natin masosolve yung example number 6. Gamit yung powers of sines and cosines of the method of integration. Okay, again, we have your example number 6, that integral of sine to the fourth x cosine squared x dx from 0 to pi over 2. Instead of using Wallis formula na nabanggit ko kanina, we're just going to use powers of sines and cosines case 3. This is part of the so-called method of integration na hindi kasama talaga sa inyong lesson. But since na meron na akong example dito, pakita ko na rin sa inyo on how to use or how to integrate sines and cosines o powers of sines and cosines using case 3. Kasi hindi basta natin to ma-integrate gamit yung basic integration formulas. So in case 3 of powers of sines and cosines, if m and n are both integers, ang gagawin lang natin, sine to the m v, cosine to the n v, ifa-factor out natin yung m and n in such a way, yung kanyang matitirang exponent is on the second degree of the function sine, ganun din on the second degree of the cosine function. Okay? So that we can apply these trigonometric identities. Sine squared v equal to 1 minus cosine 2v over 2 and cosine squared v equal to 1 plus cosine 2v over 2. Pero nung ginamit ko to on both sines and cosines, medyo mahaba ang solution. So, nag-improvise ako on how to solve example number 6. No? So, we have here integral of 0 to pi over 2 sines to the fourth x cosine squared x dx. So, finactor ko muna yung sine squared x into sine squared x times sine squared x. So, 0 pi over 2. We have sine squared x, and cosine squared x dx. Now, pwede natin itong gamitin, no? Pero nung pag ganamit natin, medyo mahaba ang solution. Ito na lang gagamitin ko, and what I'm going to do to this part of, or to this expression, gagamitin ko isang identity, which is 2 sine x cosine x is equal to sine 2x. So, therefore, yung ating sine x cosine x is the same as sine 2x over 2. Okay? So, ito. Gamitin natin. So, we have 0 to pi over 2. Sine squared x, pwede natin itong gamitin. Okay? X is v. So, therefore, this will become 2x pag in-apply natin itong identity na to. So, 1 minus cosine 2x over 2. For this one, ito naman gamitin natin. Sine 2x over 2. Sine 2x over 2. Naka-square siya. Ayan, kasi square yung product of these two. Dito kasi hindi naka-square. So, we have to square. So, we have 2 times, ito ay 2 squared is 4. 4 times 2 is 8. So, ilabas na natin yung 1 over 8. So, we have 1 minus cosine 2x. By the way, I forgot dx. This is sine squared 2x dx. So, multiply natin. So, we have 1 over 8. 0 to pi over 2. We have sine squared 2x. Minus this one, that is sine squared 2x, then cosine 2x times dx. Ito, pwede natin gamitin ito. Okay? Then ito, pwede natin mag-use substitution na lang tayo. So 1 over 8, 0 to pi over 2 is equivalent to 1 minus cosine. So, ang ating v dito ay 2x. So, 2 times 2x, so that will become 4x over 2. Okay? Minus sine squared 2x. And then, cosine 2x. Cosine 2x. We have dx. Okay? Tanggal natin to. Okay? So, isahin natin to. So, we have 1 over 8. 0 to pi over 2. We have 1 half minus 1 half cosine 4x. And then this one is minus sine squared 2x cosine 2x dx. Okay. So, by the way, I forgot 1 over 8. Dito, ma-integrate na natin. Ito, ma-integrate na rin natin. Meron tayong formula of integration o indefinite integration for cosine. Pwede na rin natin ito ma-integrate gamit yung u substitution. From here, ang u natin ay 4x. Ang du natin ay 4 dx. Therefore, du over 4 is dx. Ito naman, u substitution, ang u natin dito ay sine 2x. Ang du natin ay, derivative ng sine is cosine. So, cosine 2x times derivative pa ng 2x, that is 2 dx. So, therefore, ang ating du over 2 is cosine 2x dx. Okay. Bakit ko ginawa yon? Kasi po, ang formula ng integral ng cosine u du is sine u. Okay. Para dito. At dito naman, gamit yung ating u substitution, makikita ninyo na pwede natin gamitin yung power formula of integration. Substitute natin. One over 8 integral of 0 to pi over 2 1 half dx. Okay? Minus 1 half integral of cosine u. Okay? From 0 to pi over 2. Du natin is 4, so du over 4. This one, minus u is sine 2x, so u cubed integral of 0 to pi over 2. Ang du natin dito, that is cosine 2x dx, so du over 2. Okay. Then, we have 1 over 8. So, integral nito is 1 half x minus 1 half times 1/4. Okay? 1 half times 1/4. Integral ng cosine u is sine u. Sine u. Ito naman, integral ng u cube, that is u to the 4th over 4. Okay? Pero may 1 half minus 1 half. What's this? U to the 4th. Sorry. Sorry. This is u squared. So, u cube over 3. Okay? Simplify natin. 1 over 8 integral of 1 half of x minus 1 over 8 sine 4x. Minus 1 over 6 u is sine 2x. So sine cube 2x. Okay. By the way, I forgot nga pala from 0 to pi over 2. So, hindi na natin kailangan i-substitute yung 0, that is f of a, kasi magzi-0 din naman to. Yung pi over 2 na lang. So, pi over 2 is 90 degrees. Okay? So, 1 over 8, 1 half pi over 2. Minus 1 over 8 sine 4 times pi over 2. Minus 1 over 6 sine cube 2 times pi over 2. Hindi natin substitute yon. So, pi over 2 times 4, 90 times 4 is 360. Sine 360 is 0. So, wala na to. Pi over 2 times 2 is pi. Sine pi is 0. So, wala na rin to. So, ito na lang matitira. So, we have pi over 4 times 8 is pi over 32. So, yun ang sagot natin para dun sa example number 6. Okay? So, baka hindi na ako magbigay ng ganito kahirap na problem. So, madaling problem na lang ibibigay ko sa inyo involving sine and cosine functions. Okay? So, that is my last example about the topic fundamental theorem integral calculus. I'm going to give you activity sheet for this topic. Thank you.